This is Module 2, Lesson 1, Part 1 on quantitative data. As we begin to think about analyzing and interpreting quantitative data, there are 5 important characteristics that we need to focus on. The first is the center, which is basically what we would call an average or the value that indicates the middle of the data set. Second is variation. How much do the data values vary among themselves? How different are they? Third is the distribution. The nature or the shape of the distribution. Are the data clumped around a value at the center? Are they clumped together at the low end or the high end of the data values? Fourth is outliers. Outliers are those data values that, for whatever reason, do not seem to fit with the rest of the data set. And then finally, number 5 is time. We all know that things change over time, and so does data. Hopefully, you'll recall from an earlier lesson that quantitative data is numbers, it's counts or measurements. And it is used quite often within research. And whenever we're conducting research, trying to answer a research question, the first thing we have to do is organize our data in a meaningful way. And one of the tools to do that is to use what's called a frequency distribution. Once we have the data organized, we need to be able to communicate that information to our audience. And one of the best ways to do that is to use graphs. And this lesson explains how to organize and display quantitative data using those 2 tools. We're going to focus on the organization of quantitative data first. And we're going to focus on using a grouped frequency distribution, which is an organizational tool that allows us to organize the raw quantitative data into a table form. Typically, a grouped frequency distribution will have 3 to 4 columns. The first column represents your numeric groups or your class. We list those groups numerically in order with no jumps or skips within the numbers. And each group, instead of having a single individual value, will have a range of data values. That's why we call it a grouped frequency distribution. The second column is the tally column, where we indicate that a data value has occurred within that particular class. Third is frequency. The frequency is the number of times that class occurs within the data set, and it's written as a whole number as opposed to using a tick mark. And the fourth column is the relative frequency, or the proportion of the class that occurs within the entire data set. Relative frequency is written as a percentage and is used primarily to make comparisons between data sets that are different sizes. There is a formula for calculating relative frequency. It is the frequency of the class divided by the sample size multiplied times 100%. We also use the grouped frequency distribution as a jump start for some of the graphs that we're going to take a look at a little bit later in this lesson. There is one disadvantage to using a grouped frequency distribution, and that is that we lose the raw data, meaning that we cannot take the grouped frequency distribution and recreate the original list of data. So we're going to take a look at how to create a grouped frequency distribution. And the example we're going to use asks the question, what is the average age in years of students taking classes on the GHC Cartersville campus in spring 2018? And you have the raw data that was collected there. There's no sense of organization to it. It's just a random list of numbers, and we want to try to organize it. The first thing we have to do is kind of plan out what we're going to do and how we're going to set it up. So we have to decide on the start value for the first group or class. The start value of that first group has to be equal to or lower than the minimum value within your data set. That minimum value in each group is called the lower class limit. Try to use what I would call kind of a nice start value. It doesn't have to be the exact data value. You may want to think about using numbers like 0, 5, 10 as you make your selection. For this example, I would probably choose 15 as my start value since the lowest value is 17. You want to decide on a scale. The scale is called the class width. Again, you want to think about, you're going to count by 2s, by 5s, by 10s. Again, what kind of scale are you going to use? Choose one that makes sense for the data, for your data set. And for this one, I would probably choose a scale of 5. Then we got to set up our groups. So we begin with our lower class limit value that we selected. We add the chosen class width, and that gives us the lower class limit for the second group. And we continue that process until we have a group that will include the maximum data value in the set. Then you have to find the ending value for each group. The groups cannot overlap. You only want the data value to fall into one group. So you got to use some brain power and ask yourself, what is the highest value that I could use in the group without overlapping the second group? And your answer becomes the ending value of the group. And then we add the scale to that upper class limit, as it's called, until we find all of the ending values for the groups. So let's actually do this. Okay, so we set up our table, 4 columns. The first column will be our groups, the second tally, third frequency, fourth relative frequency. We selected 15 to be the start value of the first group. So then we add our scale to get the second group start value. So 15 plus 5 is 20, plus 5 is 25, plus 5 is 30, plus 5 is 35, and so forth until we get to 50. I stop at 50 because if I add 5 again, that's 55. And since our maximum data value is 54, that's too high and not necessary. To find our ending value of each group, again, I ask myself, what's the highest value that can be in the first group and not overlap with the second? Hopefully you realize that's 19. And then we add our scale to the group. 19 plus 5 is 24, plus 5 is 29, plus 5 is 34, and so forth until we get to the last group, which has an ending value of 54. So now we have our groups established. We have 1, 2, 3, 4, 5, 6, 7, 8 groups. We're going to go back through our data set, and each time that a value occurs within that group, we're going to put a tally mark. And even though there are no ages between 35 and 39, you still have to leave that list in the group because we want the numbers to be consecutive with no gaps. We then basically take our count up our tally marks and record the frequency as a numeric value. So for the first group, 15 to 19, we had 5, 10, 15, 20, 25, 26 values. So we record the frequency as 26, and we do that for each of the 8 groups. We then convert to our relative frequency. The relative frequency, the formula, remember, is the frequency of the class divided by the sample size times 100%. So for the 15 to 19 age group, you would have a frequency of 26 divided by 50, which was our sample size, times 100%, which is 52%. And again, you continue that for each of the 8 groups. A couple of things to point out. Your tally column and your frequency column should always equal your sample size. and your relative frequency column should always be close to 100%. If we are rounding the decimal values or the percentages, it could be a little bit below or possibly a little bit above. This is the completed frequency, grouped frequency distribution for the ages of students on the GHC Cartersville campus in spring 2018. Now, with this simple tool of a group frequency distribution, we do have our data organized, but we still can't really answer the research question, which is, what is the average age? We can, however, make several observations. Approximately half of the students are between the ages of 15 and 19. Approximately 80% of the students are 24 years old or younger. About 6% of the students are 40 years or older. So this is the simple organizational tool that we're going to use to help us organize our data. In part 2 of the video, we're going to look at the different graphs that we could create and display to our audience.